Hello and hi to Dr. Chen. My name is NURUL ILYANA binti RAZALI. My matrix number is A175674. Types of coating me and my partner have chose is porcelain animal coating focusing on cooking pan. Porcelain animal coating is an inorganic type coating which is applied to metals or glass for both decorative and functional purposes. This coating is a silica-based solidified glass mask obtained by high temperature firing, which is temperature can range between 450 and 1200 degrees Celsius depending on the substrate. Porcelain animal coatings differ from ceramic coatings mainly by their glass structure and dilatation coefficient, and from organic paints mainly by the inorganic nature of the matrix and the chemical bond that exists between the coating and the substrate. These are the coating properties requirement. First, thermal properties. Animal coatings can easily withstand with high temperatures, contact with direct flames and thermal shock conditions, mainly thanks to the vitreous nature of their matrix. All animals are almost resistant to temperatures up to 400 degrees Celsius, and this is the main reason why they have been used for a long time to produce pans and kitchenware. The resistance to high temperatures and thermal shock are interesting properties. Another important aspect to consider is the fireproof property of animals. In case of fire, animals do not release toxic gases in the environment and limit the propagation of fire. Next is physical properties. The surface of animals is very smooth and glossy, although it is also possible to produce matte coatings with the addition of opacifying agents. The animal surface is also free of open porosities, thus the growth of bacteria and fungus is somehow hindered and the accumulation of dirt is limited. In addition to that, animal materials can withstand the frequent use of disinfectants, thus being an excellent solution for the cladding of surgery wards and similar applications. The microstructure of animal coatings is also important in determining the protective properties toward the covered substrates. One of the examples is soil corrosion resistance. It is specially formulated. Porcelain animals with good continuity provide excellent soil corrosion resistance. The formulations used are those that are resistant to both acid and alkaline groundwater. After that, chemical properties. Animals commonly show a high resistance to chemical agents, but their degree of resistance largely depends on the application purpose for which they are formulated. In general, it is possible to state that animals are resistant to most solvents, acid, and neutral solutions, while they are easily attacked by solutions containing fluorides and strong alkaline boiling solutions, which is pH greater 12. Their resistance to solvents makes them suitable to be used in environments where cleaning with aggressive detergents is carried out frequently, such as in road signs and architectural panels in stations and subways. For example, the acid resistance of porcelain animals can vary widely depending on composition and to some extent the processing used. Even such corrosive media as molten metals and vapor phases present in hot gases have been confined within porcelain animal structures. The degree of attack by acid solution on porcelain animals appears to depend less on the type of solution than on its pH. The highest degree of acid resistance is obtained by sacrificing other desirable properties such as alkali resistance. To achieve maximum service conditions, a proper balance of acid resistance, alkali resistance, and other properties is necessary. Carry on, mechanical properties. Their hardness can be greatly improved by the addition of additives or hard particles. The glassy nature of animals plays both a positive and a negative role, as it is the main cause of the low resistance to mechanical shock. Despite their low mechanical properties, animal coatings are able to withstand a certain amount of bending without the formation of cracks.
Hello, my name is Nawal Khalis binti MUSTAPHA and my matric number is A174852. So, I am going to talk about process or methods. Before beginning the enameling process, the substrate surface must be thoroughly cleaned to eliminate any remaining chemicals, oils, rust or other pollutants. For surface preparation, First, the pen's rim was rounded and the corners were sanded. The pens were then placed in a sandblasting chamber. After that, the sand was scrubbed away with an abrasive pad. As a result, the enamel coating may adhere properly. Next, the dry powder electrostatic technique is employed for the enameling process. A spray gun is used to apply an electrostatic charge to the powder particles, which are subsequently drawn to the grounded section by the charge. The fluid is electrically charged and sprayed to the pens. The glass powder is then deposited on the metal and its electrical charge is transferred to it, so we can have a homogeneous and thick covering. Following the dry application, the enamel is dried up with a mild heat treatment to eliminate any remaining water. The coated pens are then passed through a tunnel furnace to vitrify the coating layer and create an irreversible enamel metal addition. Ground coat, which is metal layer with borosilicate, which is enamel layer. Firing temperature is approximately 820 to 880 degrees Celsius, whereas for cover coat is about 800 to 850 degrees Celsius depending on the materials. The powder melts, flows and hardens to create a smooth, long-lasting vitreous covering. Then, after firing, the cover coat is applied to give a smooth and beautiful surface as well as stable physico-chemical property.
Furthermore, the inspection or standard of coating according to International Organization for Standardization. First, ISO 2746 in 2015, vitreous and porcelain enamels, high voltage test based on the values laid out in the standard. The correct voltage can be set directly on the probe head. Porosity testing ideally takes place right after the enameling process. The voltage applied is typically between 12 and 20 kV depending on the thickness of the enamel layer. Secondly, ASTM C74387 in 2018 standard test method for continuity of porcelain enamel coatings. This test method provides for easy detection of discontinuities and areas of light coverage that are not readily seen by visual inspection on corrosion protective porcelain enamel coatings. These two issues limit the protection to the metal substrate. Thirdly, ISO 4532 in 1991, vitreous and porcelain enamels, particularly for the protective function of coating materials, the ability to withstand mechanical impacts is of vital importance.
Now, let's talk about coating lifetime and failure. The design specification referred to Porcelain Enamel Institute standards, which indicate a coated service life of 20 to 30 years with minimal maintenance limited to routine cleaning. Porcelain enamel pens are a worthy investment. However, there is no rose without a thorn. Porcelain enamel cookware was once thought to contain dangerous quantities of lead and cadmium. To be safe, buyers should only buy high-quality products from well-known companies. Lower quality porcelain enamel has a thinner layer that is more likely to crack and chip, affecting the cooking experience dramatically. Dropping porcelain enamel cookware can also cause the surface to break or chip. Mechanical stress and high abrasion phenomena may cause the nucleation and development of cracks inside the material, compromising the coating's protective characteristics. When washing the cookware, be gentle, because the porcelain enamel coating on is fragile. It is advisable to hand wash it and avoid steel wool, which can harm the coating. Make sure there is no food residue left on the pen surface for an extended period of time, since this might cause chipping. Some varieties also cannot be left on high heat for long periods of time.